In this video, we'll see how to find the least common multiple, or LCM. First off, let's get a definition. The least common multiple, that is the smallest number that two or more numbers will divide into evenly. That means there's no remainder when you divide with them. We can use the ladder method to find the LCM. We're going to divide out the GCF and then divide until each number becomes a 1 at the bottom of the ladder. Finally, we'll just multiply it by the numbers we divided by to get the LCM. So let's say I wanted to find out, if I wanted to compare 7/16 and 9/20, and I wanted to see which was larger and which was smaller, and I wanted to use the LCM to help me do that so I could rewrite the fractions with the same denominator, making them easier to compare. Well, first thing I'm going to do is I'll use my ladder method, and I'll think about what goes into 16 and 20. I know 4 does. 4 goes into 16 4 times. It goes into 20 5 times. 4 and 5 have only one common factor, which is 1, which means this 4 here, that's the GCF. Now to find the LCM, I want to keep using this ladder and dividing until I get 1s at the bottom. So 4 divided by 4 is just 1. Then I'm just going to bring down the 5 since 4 doesn't divide evenly into 5. And then I'm going to divide by 5. And I see here that 5 doesn't divide evenly into 1, so I bring the 1 down. 5 goes into 5 one time. I've got my 1s at the bottom, so now I just want to multiply these numbers. 5 times 4 is 20, and then 20 times 4 is 80. The LCM is 80. So if I wanted to compare these two numbers, or these two fractions here, I could rewrite them with a denominator of 80. 20 times 4 is 80, so I have to multiply 9 times 4 to get 36. And then 16 times 5 is 80, so I have to multiply 7 times 5 to get 35. And I can see that 35 eightieths is less than 36 eightieths, so that means 7/16 is less than 9/20. I can also find the LCM of variable terms, right? I just want to try to find the smallest number that both terms will divide into. So if I think of v to the third and v to the fifth, well, v to the third is this, v times v times v, and v to the fifth is this, v times v times v times v times v. Well, what's the smallest thing that both of these will fit into? Will both v to the third and v to the fifth divide evenly into v to the third? Nope, they won't, because v to the fifth won't divide into that. Now, could both v to the third and v to the fifth divide evenly into v to the fifth? Yes, they can, because v to the fifth divides into this one time, and v to the third, we can see it fits in evenly right here with v squared left over. So the LCM will be v to the fifth. Let's look at c to the third, f to the fourth, c to the sixth, f squared. Again, let's try to think about these things. Well, what's the smallest thing that c to the third and c to the sixth will divide into? C to the third, c to the sixth. Well, c to the sixth can't fit into c to the third, but c to the third can divide evenly into c to the sixth. So I can see that c to the sixth will be part of my LCM. And then I have f to the fourth and f squared. Well, what's the smallest thing that f to the fourth and f squared will divide into? The smallest thing that f to the fourth and f squared will divide into is going to be f to the fourth. So my LCM is going to be c to the sixth, f to the fourth. Notice what we did for both of these here. Basically what we're choosing is we're choosing the highest exponent for each of those bases there. So c to the sixth, f to the fourth. I look at v to the third and v to the fifth. So I just choose v to the fifth. Let's see what we do if I have a number that's a mixture of variables and coefficients, or two numbers, and I want to find the LCM. I'm going to use my ladder for the coefficients, so 12 and 16. I want to find the LCM of 12 and 16. I know 4 goes into both. 4 goes into 12 3 times, goes into 16 4 times. And then 3 goes into 3 once. It doesn't go into 4, so I carry it down. And then I can divide by 4, and I get my 1s at the bottom. 4 times 3 is 12. 12 times 4 is 48. So 48 is the coefficient. I look at the variables, the least common multiple of d to the third and d to the fifth. Well, the smallest thing that both will fit into is d to the fifth. Then I see f to the fourth, and I don't see an f variable here. Well, I need 12d to the third f to the fourth to divide evenly into this LCM, so I just need to include f to the fourth here. If it helps, you could think about it as if there was like an f to the 0 here, because that's just equal to 1. All right, here are a couple problems for you to practice on your own. If I have x to the third, y to the fourth, what's the smallest thing that both will divide into? Notice that the bases are not the same. Well, x to the third will divide into x to the third. Y to the fourth will divide into y to the fourth. So the smallest thing that these both will divide into is x to the third, y to the fourth. Remember, I want to choose the highest exponent here. So c to the third, c to the fourth is just going to be c to the fourth. And d to the fifth, d to the fourth, d to the fifth is the highest exponent. This is the smallest value that they will both evenly divide into. I can use my ladder for 42 and 98 to find the LCM. I know that 2 goes into both of these. 2 goes into 42 21 times. It goes into 98 49 times. I know 7 goes into both of these. 7 goes into 21 3 times, and into 49 7 times. And then I can just use these numbers down here, since there's nothing except for 1 that goes into both, and bring down my 7. So my LCM is going to be 2 times 7 times 3 times 7. I know that 7 times 7 is 49, and 49 times 2 is going to get me 98, and I can multiply 98 times 3, and I'll get 294. So 294 is my LCM. And finally, for 18m squared y to the fifth, 45m to the third y, again, I'm going to look at my coefficients, take the LCM of my coefficients. What goes into 18 and 45? 9 does. 9 goes into 18 twice, into 45 5 times, excuse me. And then I see that these have no common factors except for 1, so I'm going to divide each of them. 2 goes into 2 once. It doesn't go into 5, so I bring it down. 5 doesn't go into 1, so I bring it down. 5 goes into 5 one time. So the LCM of my coefficients is 5 times 2 is 10. 10 times 9 is 90. Then I just look at my variable terms. M squared and m to the third. What's the smallest thing that those m's will go into? It'll be m to the third. Y to the fifth and y, the smallest thing they'll go into is y to the fifth. So that's my LCM.